Greetings, you're watching this video after you take the FastBridge today. So we're going to look at solving linear inequalities in one variable. So before we solved linear equations, now we're going to just throw an inequality symbol in there. And those are greater than, less than, well in this case less than, greater than, less than or equal to, or greater than or equal to, these symbols. So we're going to use those instead of an equal sign. Now the only thing different than when we deal with these, if we divide or multiply by a negative number, we have to flip the inequality sign. So if you follow along with your notes, go ahead and solve these and then we'll check them. So I would put this on pause, solve them, and see what you get. And I'm going to go ahead and x is less than 11 halves, or 5.5. And that would be 5, correct? Divide by negative 6. We have to flip the sign because we're dividing by a negative. So we get x is less than 11 halves, or x is less than or equal to negative 5/6 on the other equation, or inequality. Okay, so we treat them just like equal signs, except when we need to divide by a negative. Or we could also multiply by negative and have to do the same thing. So if we have a less than or greater than symbol, we use an open dot to indicate on a graph of an inequality that that number is not a part of it. If we have an equal sign, we use a solid point because that is a part of the solution. And when you make a number line, you need at least 3 numbers on it. So we're going to make this pretty simple for you. We have two types of ways, by the way, with notation: inequality notation and interval notation. So interval notation, x greater than 2, means everywhere beginning at 2 going to infinity. We read left to right, so it's 2 to infinity. So then, if we graph this, if we graph this, that means we're going to start at 2 and go to infinity. So it's going to look like that because we have a open point at 2 because we don't have an equal sign on that. Now interval notation, again, we'll go over this again in person as well. You can ask me while people are working on the FastBridge or Mrs. Coffee. The next problem says x is less than or equal to negative 4. So if it's less than, that means clear to the left. So that would be negative infinity, which is left, up to negative 4. But notice we have an equal sign. So in interval notation, we use a bracket. So it's negative infinity to negative 4. If we graph it, we have negative 5, negative 4, negative 3, negative 2, blah, blah, blah. And this is from negative infinity to up to negative 4. So that's going to be filled in, and it's all the points coming from the left up to negative 4. The third one here is from negative 3 to 1. So this is interval notation. Notice we use parentheses because it's not equal to. We use brackets because it is equal to. And when we graph this sucker, so 0, this is 3, so 1 would be about there. This would be filled in. This would not be filled in. And there is the solution to the graph. I encourage you to pause this and kind of look through it for better understanding. 4 and 5 we're just going to simply solve here, just like we did before. So we would subtract negative 6, so subtract 6, and then divide by negative 7. So x is less than 1. We would have to switch the inequality. Now, what would that be in interval notation? Negative infinity to 1, because everything is less than 1. How do we graph it? Well, let's see. Here's -1, 0, and 1. We need everything left of 1, but not including 1. So there would be our graph right there, going to the left. Number 5, we got to solve for x just like we did before. And really the only different thing is that we need to flip the inequalities. That's really the only difference if we divide by a negative. So we get x is greater than or equal to 3. So this means that we're going from 3 to infinity, but it is included. So 3 is a part of the solution, so that's filled in, and we're going to infinity because it's greater than. So there's our graph. Okay, a couple more here. Now, this one is written kind of confusingly, but all that means is this. We have two equations. 5x minus 2 is greater than -7, and 5x minus 2 is less than or equal to 8. So we just solved both of them, as is. Divide by 5, x is greater than -1. Add 2, you get 10 divided by 5, x is less than or equal to 2. So we're supposed to write this in interval notation, right? Well, it says that x is greater than -1, but less than or equal to 2. So that means I'm going to go to -1, from -1 to +2, and 2 is a part of the solution, so we use a bracket. On the number line, we would have -2, -1, 0, 1, 2, 3. I'm just drawing point. Guys, it doesn't matter. Just make sure you have 3 points and it works. So those are all the solutions to this inequality. Anything between -1 and 2, including 2, but not including -1. So on 4, we're going to do the same thing. Split them up into 2 functions, like so. Subtract 5, you get -1. Divide by -9, we're going to have to flip the sign. So x is less than 1/9. These are going to be weird numbers. That's okay. Oh, we divided by a negative. We got to switch the sign. 3/9 is 1/3. So this says that we are greater than -1/3, but less than 1/9. So those are going to be parentheses. Now you're thinking to yourself, wait a minute, where in the heck does this lie? Okay, well, -1/3 is about right there. 1/9 would be about right there. We're talking about those solutions in between. Those are the two solutions with open circles because we don't have an equal sign, a less than or equal to sign, or greater than or equal to sign. Okay. Lastly then, we're going to keep going and solve ones like this. Oh, wait a minute. If I subtract 2x and then look at the problem, is -8 greater than 1? No, so it's no solution. So we don't even have to mess with it. We're done. Number 9. Remember how we get rid of fractions? We do not like that 8. We multiply by 8. So 5z minus 6 is less than or equal to 64. Add 6. 5z is less than or equal to 70. Divided by 5. Z is less than or equal to 14. So that means that all the numbers below 14 and including 14 are solutions. So if we put that on a number line and say this is 15, 14, 13, all solutions below 14, including 14, are acceptable for z, because anything bigger than 14 doesn't work. Now we're going to do the same thing on this one that we did 2 slides before. We're going to go ahead and split this up into two equations. And yes, we want to multiply by the denominator. And we're going to add 5 and divide by 2. Again, just pause it when you're doing these, going through these together. And on this side, we're going to multiply by 6 and get 2x minus 5 is less than 30. Add 5, we get 35, divide by 2. I'm going super fast because I don't want to take up your time. So x is less than 17.5, but it's greater than or equal to negative 1/2. So interval notation, let's see, 35 halves, 17.5. If I leave it in fraction form, it looks like that, and that would not be bracket. You're right, you caught me. That would be a parentheses, because it's not including 17.5. We could also do this. I know people like decimals better than fractions. And then obviously we can graph it too, and put 0 here and put 18 here, so we know that it's going to be about, I don't know, I'm guesstimating there, we're guesstimating there, but it's these numbers in between, from negative 0.5 to 17.5. Now work on your MyMathLab assignment, and good luck. Ask a lot of questions.